Okay, so why do I think I discovered warp drive theory? Well, it has a lot to do with everything in the past coming to the future. Uh, Start off with Newton, the tablecloth experiment. Maybe it wasn't even done by Newton. The tablecloth experiment. Put a bunch of things on a table with a tablecloth, and then you pull on the tablecloth. If the tablecloth moves quickly enough, then the energy doesn't move into the other objects on the table and they stay in place. This is the exchange of force, and it could be looked at as an opinion of what is gravity, and um, like the sun sits at the center of the solar system, the least least motion. All right, I'm gonna go ahead and move on to the three objects that have a correlation but don't seem to. A top and a pry bar and gravity. What do they have in relation? They are very much related. Maybe you don't see why, but I'm going to explain that to you, and then you're going to see a correlation. And this correlation is going to be later, it's going to be known through all of science. It's going to be something it's going to be one of the key joints in everything. Um, okay, so let's go ahead and start off with the top. You spin a top. Where on the outsides of the top, it's moving the most quickly, and then the center is moving the least, and the top seems to want to stand on its center where it's spinning the least. And you can also put a top at an angle and it will still stay at the angle. Why does it stay at the angle? We can only make a statement here. It's moving the least and it's carrying the most amount of mass. Let's go ahead and move on to the pry bar. The pry bar, the part that moves the least, can carry the greatest amount of force. And the part that generates the force has the greatest amount of motion. And if you transfer the motion to a lack of time, then it creates a greater force. It carries a greater force. Make the pry bar longer, it pushes over a longer distance, and make the tip of the pry bar shorter, and it generates more force. Well, it's an exchange. I can't tell you that yet. Okay, well, let's go ahead and move on to gravity. What is gravity? People have been thinking about this for years. It's a contortion of space and whatnot. Well, it is, but what is all that? Well, the three things have one thing in common, and that is a differential in time. And all matter is made up of time. What is matter? Matter could be looked at as space with time. Or you could just say it's little fragments of another universe and it's moving. So the reason why they exist is because they exchange time. So that is a correlation. So the reason why gravity pulls you down, it has something to do with a differential in time. The closer you get to the planet, the more quickly time moves. So the further you get away, the slower time moves. So actually, when you're flying or when you shoot a bullet and the bullet wants to go down, time accelerates and the force, it moves to the center of force, where it can move the least. And the place where an object can move the least is at the axis, as we know from looking at pry bars and tops. So that's where objects actually want to go in general, caused by a contortion, a release of time exchange. And the release of time exchange is what we know as gravity. So the objects that I plan on using are called virtual particles, and the theory is Well, my theory in general is we have our universe and the other universe, and in the beginning there was a great vacuum, and the great vacuum caused the two universes to collapse into each other, and then the aftermath was a big bang. After the big bang, you still have like I guess little wakes in the water. Like imagine a raindrop hit the water. It goes inward and then it comes out. And just imagine, it's free in space. So it goes in and out and in and out and in and out, like never ending. Eventually, the energy balances out. The sheet stretches enough that it balances out. But in my theory, the more space expands, the more in and more the more droplets form. And I think these droplets are they're like sparks in water. So by creating a vacuum, I'm going to be able to generate more. That's the theory. Now, whether that's how you get virtual particles to increase or whatnot, I don't know. It doesn't really matter, because if virtual particles exist, there is a way to push against them. Because you could look at them as just a wake on water, and you just have to think about how to move by a wave, how you can surf on a wave. These don't have the same properties as regular matter, and they don't act the same way as normal matter, but we can definitely poke at their existence and find out how we can make them tick. The warp drive will work in a special way. What I do believe, I feel quite certain about, is that, well, science is a perception of how you see something. So maybe you perceive something this way, but it's not really correct. It doesn't work out 100% in the end. And I believe that Einstein was also in that zone where he couldn't see quantum entanglement, but he could see black holes and wormholes. He could see that mass couldn't be destroyed, and he could see that time travel wasn't possible, but he didn't know why. Maybe I should make that statement about time travel. What is time? Well, in most cases, time is what we use to measure differential in space. And you would have to look back at what matter is. Space with a contorted space with time, a certain amount of time. And then there's a time differential in between. And then inside those, there's another time differential. Like, go down to quarks, go down to photons. And then, how many photons does an atom have? Do photons are they absorbed by atoms? Does a atom actually look like a solar system with a bunch of meteors in it? In my idea, the way I see the universe is that if you looked at an atom at a very small scale, then you would see like a hurricane, and then around the hurricane you'd have a bunch of little tornadoes. And in some cases, the tornadoes are popping in and out, popping in and out. And maybe that's why they picked up where the electron moves from one place to another, giving off color. Maybe that does work. I don't really believe so, but maybe it does. Maybe electrons do pop in and out because of an interaction of something in the field. I don't know that stuff, but I do know that there is a correlation between time and matter has everything in the world to do with a time exchange. By exchanging force with a certain amount of mass, you get a certain amount of velocity out of it. And mass has something to do with a distance in some way, shape, or form, whether you're trying to calculate its axis or its diameter, and you're going to calculate its diameter and find out a certain amount of distance that it has in correlation to space. You're going to correlate it to something else. but in all cases it can add up to this amount of space against this amount of space equals this amount of acceleration in space. And that's what I believe that you're going to actually look at if you actually start designing a warp drive, a real existing warp drive. It's going to be along these lines of this new theory of looking at matter as more of an exchange of space to space. And that's if the warp drive actually works, that's going to be the cherry on top of science as we know it. It's going to be like, what is the existence of everything, and we have the answer. That's what it's going to be about. So I do believe that the warp drive is going to work, and I don't know what design is going to work because I don't know how to probe quantum particles. But I'm going to start probing quantum particles, and I just finished one piece of the warp drive cylinder today. So that's it with the clamps on. That's what it looks like as it's finished. Well, the first test cylinder. Alright, so this part is the piece I was talking about. This is the guide vane. A little piece of glass on the inside. So let's go ahead and wait. Let's go ahead and just take. Oh no. Yeah. Oh jeez. So that is where the radio waves bounce around. Let's go ahead and take that off. Well, the bracket's not. The bracket's not on yet. So this is inside the guide vane. You see that little plate, and then under that little plate is where the microwaves come out. And then the microwaves go through a piece of glass and then enter in the chamber. When I vacuum out this cylinder, I believe that it's going to start inducing a motion where there is a lack of. So quantum particles will start popping up, popping in and out of existence more inside this chamber when it's all vacuumed out. And then it's going to interact with these particles and cause them to move closer to the surfaces inside. All right. So far, the surfaces inside are metal, but I also have different types of materials that I'm going to use inside, like glass and whatnot. And the reason why I'm going to be using different materials just for this one type of test. This one type of test is going to use like scoops, and the idea of the scoops is on the inside of the scoop, the waves hit the interior, and then space. The quantum particles hit the outer walls of this circular shape, and then they're pushed inward. And then, like when they disappear, they become space again. And when they become space again, they become a correlation to space moving. So space keeps moving, and it creates a differential in time. So it's like gravity. So there's a generation of gravity on the inside of the scoops caused by an interaction with the quantum particles. And then on the outside of the spoon, when the quantum particles hit it, then they're going to be pushed outward. So I believe that this is going to cause a not an anti-gravity, a reverse gravity. So space is actually starting to push outward on the one side and pushing inward on the other side. And you could imagine like looking at the scoop, and you see that the compression of space is going to be a semicircle, but it's going to be basically wanting to eat up space. So on the interior of the spoon, these scoops, and that's where it's going to pull space in, and then it's going to spit it out on the other side, on the outer edge of the scoop. And so it works the same way. The idea of how it functions is it's going to be working similar to a jet engine, where it sucks in air and pushes air out. But in this case, it's actually doing it to space. And how does that correlate to how does that correlate to matter's mass? Well, you have to be able to calculate how much space is in, or how much moving space is inside mass. Nobody knows that yet, but it will move, even though the space equals nothing. Uh, if you go down to it, then all the mass in the universe have nothing more, no more mass than a drawing does on a piece of paper. Nothing has any mass. It's just an exchange of a time and space. It equals a time and space. So it will equal motion in theory, and it will turn into propulsion, an actual type of propulsion. That's why I believe warp drive will work. This first warp drive, uh, if it works, I believe it's going to have like a propulsion uh, aspects about it. It's going to want to move. I don't believe that people had it right. I don't believe that warp drives don't want to move. You had to push a little bit. No, warp drives want to move. It's like the actual physical motion of an object. That's the actual existence of it. Now, uh, the deal is how fast objects can actually move in space, and that is because it's restricted by how fast photons are always moving. Photons always move at the same speed. They never change speed. They always move from point A to point B, move into an orbit or whatnot, but they always stay at the same speed. They just never slow down. They might be grabbed by something and obtained, but they never lose their speed. It always stays the same, even inside matter. So it always has a direct correlation to from its speed to how many how much speed does mass have. It's all going to go down to there are this many amount of photons inside it. Um, so they're always there. Um, in that is that was just about the correlation between the speed of light and gravity. What black holes. But really, I can't go into that because I don't know that stuff really well. I'm just running with a theory that I created back in high school, and never I was never differed by it. It adds up, and it just becomes more. It doesn't become less. It just becomes more. It's just my theory, and if you look at it, if you think about this stuff relative to what they're doing in science now, then you'll start seeing that, yeah, there's something a little off. There's something a little off when Einstein made friends with the guy that made the the guy that made quantum physics. It doesn't make sense when you try to say like weird stuff like there's a cat in a box and it's dead or alive. So uh, it's like time. What is it? Oh, it's like cookie dough. Well, how do you go back in time? Well, you just got to take out all the chocolate chips and the flour, and then you take out the milk, and then what do you get? Like, you get flour and chocolate chips. Now, let's go ahead and go back in time and like put the flour and the chocolate chips back inside. Like seriously, is that time travel? No, no, it's not. It's not time travel at all. But that's the way that people are looking at it. Like, yeah, you can time travel this way. No, you can't. If matter really is like an exchange of time and whatnot, you can't really take out the cookie dough. You can't really take it apart in fragments. Otherwise, you're just going backwards. But it's not in time. It's you're taking out the ingredients and putting it back together. It's like in that aspect, there is no meaning. So yeah, you can't go back in time. It has everything to do with our existence. You're either talking about putting us together or taking us apart. If you're talking about like the whole universe, like coming apart, and or wait, all the photons start going in reverse, and you stay the same. That's not really. That's not really. That's just taking out chocolate chips. It's not really going back in time. I mean, you think about like how are you gonna do that? You're gonna like inject them with energy. You're gonna inject it in yourself. If like the cookies, if all the chocolate chips are in the cookie dough, and you inject something into yourself, then what about the cookie dough? Does it like move back? No. Well, anyways, uh, on that, time is not like fragments. It's not like a book. You can't go back through time. Um, Time is something that's more of a geometry, and it's always changing, but it's the same geometry. You can't change. You can't geometry the geometry. You can't do that because that's our sheet of paper. That's where we stop. That's where our control stops, is the geometry that we're in. That's why we can't time travel, and that's why Einstein couldn't answer, because he didn't actually know that. But he did. He just, in in the way that he perceived it, he could only say, "You can't time travel." And then then his student said, "Well, I believe you can." And then they tried to run an equation where they're looking at if space was shaped differently. So things weren't correct, and I believe that the warp drive would definitely correct the uncorrectness. I believe that, as for quantum physics, that's not really the way to go. Like, quantum wave theory was the most correct, where there are waves in the universe and the quantum particles are riding on it. So they're not here or there, possibly here, possibly there. They're actually bouncing, and they're here, and they're there, and they're here, and they're there. But they're not here and there. They're just bouncing. That's the difference between quantum theory and quantum wave theory. It's just recognizing that there's like something else going on. And I believe, like I said, science is a perception. So having the correct perception of the universe is going to accomplish a lot more than somebody that has the wrong perception. They're going to bump their heads. It's like it's it well, it's like when I was in school and we were supposed to be doing a report, and then my teacher said my teacher's question for the report was, how was the universe created? And then like about 90% of the people just said something about like how God made it. And then I was like, yeah, there was this great vacuum and it sucked the universe inside out. There were two universes that sucked each other inside out. And she's like, wow, that was the most unique report I've ever gotten. You're going places. Like, yeah. Yeah. Yeah, definitely. Way, way out there. All right. Well, that's what I have, and that's why I believe warp drives will work. So keep that in mind. Space for space.